October 21st, 2020 lesson. All right, so we are going to talk about the greatest common factor and the distributive property. So we know how to do the greatest common factor. We did that last week. We also know how to do the distributive property. We ended last week with it and began this week with it. So now we're going to combine them together and we're going to see how we can use both of them. This page is just as a reference. If you want to click on some of these pictures, it will take you to the math notebook. It can also take you to some explanations, and this one will actually take you to a video of someone other than me if you want to hear a fresh voice. And you can still find it if you click myself as well. Just kind of give you more of a background and more explanation on the greatest common factor and the distributive property. So when we go to the next page, here's how we're going to do it. This might look like a lot, but take a deep breath. It's not very bad. So step one, we are going to, so first of all, is our example, we're going to factor the expression below to represent the distributive property using the greatest common factor. So we are going to use the distributive property as well as the greatest common factor. So we are going to use both of those and put them together. All right, so first of all, step one, find the greatest common factor of the given numbers. So of 45 and 60, we are going to find the greatest common factor. So we're going to factor both of these numbers. That's it. I am actually going to make these a little bit more separated so that we have a little more room. So we have 45 and 60. Now, again, or as always, there are many ways you can factor these. So 45, you can do anything. You can do 15 times 3. You can do 9 times 5. I'm going to do 9 times 5 because that's typically what a lot of students will come to their heads first. So I'm going to do 9 times 5. 9 times 5. Now, are either of those a prime number? Yes, 5 is a prime number, because the only two factors are 1 in itself. So I'm going to circle that 5. That circle was not very good, so I'm going to make it a little bit bigger. There we go. All right, so now I'm going to make these go in front of the letters too. Perfect. Okay, so now we are going to factor down this 9. Well, I know 9 is, I'm going to move these a little bit down. All right, so I'm going to move these down. Actually, I'm going to move them up. There we go. So now I know 9, we can factor it down into 3 times 3. 3 times 3, now, we all know, is 3 a prime number? Yes, it is, because the only two factors are 1 in itself. So I'm going to make that a little bigger, copy, paste. So we're going to circle that 3. Now, there's nothing else to break down for 45. So the prime factorization of 45 in order from least to greatest is 3 times 3 times 5. Bada bing, bada boom. Easy peasy. Let's try 60. What times what equals 60? The most obvious one is 6 times 10. 6 times 10. If you do it a different way, that's absolutely fine. So I'm going to do 6 times 10 here. Now, can I factor these down? Yeah, I can factor both of them. Neither of them are a prime number. So 6 and then 10, we can factor both of them. Ooh, it's going to look like a pretty Christmas tree. All right, so 6. What times what equals 6? 2 times 3, not 3 times 3. Remember, 2 times 3. 3 times 3 is 9. So now 2 is a prime number, so I'm going to circle it because the only two prime factors are 1 in itself. Same thing with 3. That's a prime number, so we're going to circle it. How about 10? What times what equals 10? Oh, 2 times 5 equals 10. Easy peasy. Is 2 a prime number? Yes, it is. So I'm going to circle that because the only two factors are 1 in itself. Same thing with that 5. The only two factors are 1 in itself. So now there's no more branches to break down. So in order from least to greatest, our prime factorization of 60 is 2 times 2 times 3 times 5. I put those numbers down first so that I can remember what I have written down. Now we match our socks. So we go to the laundry room here and we're going to match our socks. Do they share a 2? No. Do they share a 3? Yeah, they actually do share a 3. I'm going to highlight that in orange. Whoop, not 2. They share 3. Do they share another 3? No. How about a 5? Do they share a 5? Yeah, they do. We're going to do that in blue. Ooh, pretty colors. All right, so now remember we take one of each of these numbers. So I'm going to do this on the side kind of here. So I'm going to take one of each of those numbers. I'm going to take the 3, and then I'm going to take a 5. And with these numbers, what do we do with them? Oh yeah, we multiply them. So what is 3 times 5? Well, 3 times 5 I know is 15. So our greatest common factor is 15. All right, so this 15, we are going to put, so the next step after we find our greatest common factor, we are going to rewrite the number, each number, as the product of the greatest common factor and another number. So what we're going to do is, okay, so we're going to find that 15, and we're going to say, okay, 15 times what equals 45, and then 15 times what equals 60. So remember how we get to this. Well, first we would typically start off with this. This way we're working backwards. So I am actually going to move all of these up here so that we have a little bit more room. And what we are going to do is take a look at, okay, so first, didn't mean to delete that. The first thing we are going to do is, okay, so we're going to rewrite it as the product of each of those numbers. So do you remember how when we had a number in parentheses times that, and then we kept our symbol, so we kept that plus, and then we also had the other set of parentheses. So we're working backwards here. Don't make it too hard. So we're going to have that 15. It's going to have that 15. Gonna move that over here. So I'm gonna have 15 in our first set of parentheses. Actually, I should make this a little bit bigger. So we have 15. Here we go. 15, and we're gonna have 15 times something is going to be 45, and then we're gonna have 15 times something is going to be. There we go. There we go. Okay. So then we're going to have 15 times something is going to equal 60. So 15 times what equals 45? Well, I know 15 times 2 is 30. So if I do 15 times 3, that's going to equal 45. So 15 times 3, I'm going to move this in a little bit. So I have 15 times 3. And then we have our next one here is going to be what times what equals 60, or 15 times what equals 60. Well, I know that 15 times 3 equals 45. If I do another 15, that will be 60. So 15 times 4. 15 times, oh wait, no, not 4. Yeah. Times 3 is 45. Yeah. So 15 times 4 is going to equal 60. That's 12 times 5. My bad. All right, now we are going to take the greatest common factor and place it in this circle in front of the parentheses. So the greatest common factor is going to go in front of the parentheses. Inside the parentheses, we are going to take this 3. So we're going to take this 3 and we're going to put it inside the parentheses in the first spot. And then we're going to take this 4 and we're going to put it inside the parentheses in this spot. So we started with 45 plus 60. We broke it down. We said, okay, 45 is 15 plus 3, and then, or 15 times 3, and then plus 15 times 4, which is that 60. And then we took our greatest common factor, put it in front of parentheses, and then we wrote our factors inside the parentheses. And that is going to be our answer. Great job.